Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are kind of coming to the end of our debug code stuff here. It's kind of been a long road. We started it a long time ago, and then in the middle we sort of took a break and did some hardware rendering stuff. We added a hardware rendering path in addition to our software rendering path. And then we came back and kind of like solidified things, and we've got some pretty cool debug features in our engine now, which is nice. But we're kind of coming to a good stopping point. You know, we can always come back to the debug system and add new things as we need them later if we find that there's some things that it should be doing or could be doing that it's not doing for us and we'd like it to. We can certainly do that. But I think at this point we're mostly ready to sort of move on. So I'm just going to kind of be thinking here on day 268 and the subsequent streams this week, just like what are some things that we probably want to tidy up? What's some UI stuff that's not, maybe the nicest? What can we do to kind of like consolidate these things so that we can wind it down to a point where we're like pretty sure that things are working in a way that's useful to us as we move off. So, all right, and that might involve adding some features as well. Who's to say? Who's to say? Okay. So, today is day what? 268, I said. So if you would like to follow along with source code at home and you're one of the folks who has pre-ordered the game on handmadehero.org, you want to unzip day 267. That's the code that I'm starting with today. So let's go ahead and load. Let's load up here. Let's get that going and get MS-Dev going. And here is the game as it stands. Here is our profiling system, which is kind of swanky at this point. And we can use it to kind of go through and see all the information that we wanted to see. We added clipping yesterday, so we can even get some nice... everything stays contained inside our little display window, which is also good, and all that good stuff. So I would say a couple things. On the profile front, one thing that we might want to try to do is come up with some kind of memory profiling, which we could do. And I think that might be something to maybe save for next week, because one of the things that I was thinking of doing for finaling stuff before we go into the gameplay code is I wanted to show people how, like, we've kind of built this arena allocation system that's relatively primitive, but that does work very effective for what we need. One of the things I was going to show people is how you can trivially extend it to be arbitrarily growing, so that you don't have to pre-decide ahead of time how much space you're going to use. Because one of the questions that I get asked, because like the way that we do it currently is we reserve a certain amount of space and the arena allocates that space, but a lot of people are like confused about that and don't understand what they would do or how they would use it if they didn't know ahead of time that they wanted to run within a specific size. There's really no difference. You can trivially extend an arena class to grow on demand. And so I thought one thing we might do is go back and sort of maybe finalize that arena class a little bit, and I'll make it so that it can grow on demand. So that's like a feature that you could enable because it's really easy. And then, while we're doing that, I'll add the also the ability to track the allocations so that they can show up here in the debug view. And those would probably be two things that might be nice. That would be a good thing to do next week as sort of a little exercise that I think people would probably benefit from. So I think I want to stick with not that for this week. I think I want to stick with sort of more, kind of basic stuff here. And one of the things that's currently true about the system is nothing works when debug is paused. And I think that might be fine. Like, I'm not sure I actually care about that. But you'll notice, like, I can, if I want to, for example, I can actually toggle this thing and have it actually happen, meaning it's actually going to make the change. But the change itself doesn't really ever actually show up in the UI. And the reason for that is if we're not recording debug information, none of our state actually shows up here, right? We just throw out data, so it's always going to be wrong. That's something that I might consider fixing if this were a system that I was gonna, like I said, ship commercial or something. But I think that's just fine. Like I don't think that's gonna bother me at all. I don't think it's worth spending time on it, so I'm just gonna leave that be. Our system for cloning stuff at the moment is also not particularly great. There's some things that I don't love about the way the system works. So, for example, at the moment, we always have a little bit of space here at the beginning, and we get this kind of weird like dot out here. That's how you move the thing around, and there's just some. It's not the world's nicest situation. I think maybe that might be something to turn our attention to, improving that system, just making these windows work a little bit better, and maybe making better controls from the application side of things that allow me to kind of encode where I want certain things to appear and what sorts of things I want in terms of windows. And I think that might be a good thing. That's probably number one on the list today. I think that might be a good one. And the other thing I think would just be to tidy up the UI of this system, where we see, like maybe draw these thread things a little bit better, maybe make it a little easier to click or to zoom on something in particular. So just cleaning up that a little bit. Other than that, I can't think of a whole lot that would really need to be modified at the moment. It seems like things are working well enough that we can probably rely on them being good enough for us to use. Again, like I said, we have to ship the game, not the debug system. So while it's nice to have a good one, at some level you can just make arbitrary decisions of this is done enough and we don't need to polish it to any particular extent necessarily, right? So yeah, so I think what I'll do is I'll focus on sort of this overall drawing aspect of it, and that's what I think I'd like to start on. So I'm going to go ahead in and play around with that a little bit. Now, if we open up the debug code, you'll remember that this is in a thing that we called draw main menu. And draw main menu is kind of like a really weird situation. It's called main menu, but really it draws all the main menus. So it's really just the thing that draws everything, right? It's really just debug draw is what it is. And you can see where it gets called. If I go down and search for that, you can see that essentially the way our UI system actually works, for all intents and purposes. In fact, all this stuff here, our debug counter stuff, this was all old code, right? That was printing out statistics before we started working with them in the profiler. So really, all of this stuff is just vestigial remains that we don't really need. Although I guess now that I think about it, I should probably look real quick and just see what's actually there, because maybe now that I think about it, do we want to resurrect any of this and copy it out somewhere where it can be used? I suppose that's possible too. You can see here we've got. It looks like here we've got maybe some bar stuff getting drawn. So this stuff, this debug statistic hit counter stuff looks pretty irrelevant. But this stuff here looks like it's sort of that's I guess our frame bar graph. So it looks like all of this stuff we've kind of already got something of. Like all that stuff is already there, right? If that makes sense. So I don't think we really need any more of that. Let's see. Scope to record. This is all old stuff as well. We now have the ability to analyze any performance stuff. That was really old. Things that are not really at all relevant anymore. And so I think scope to record can go away entirely. And so then uh-oh. 4coder has died. Poor 4coder. 4coder has died. That's a rarity. We have not had many 4coder crashes. I believe this is the same 4coder crash that I saw before on my own work. And if I remember correctly, it's kind of a nice crash as crashes go because it doesn't kill anything. Like if it crashes when I save data, so you don't actually lose any. In fact, if I build here, oops. PRJ. There we go. If I build here, I think we're all good. Yeah. I'm not sure what it is exactly. It's something about when you run a make, there's some very specific chance that you'll crash. So yeah, this one looks like it didn't save. I'm not sure why. So it's a little bit different than mine, because mine actually did save, but definitely deleted this, right? So I'm not sure. I do not know what it actually is that causes it. At some point I'll have to debug it, but yeah. Or Alan will. All right, so let's see here. What do I want to do? I want to get rid of scope to record, and now scope to record is gone, so that's good. Let's see what else we've got. We've got it complaining about the fact that I initialize it. That's true, but goodbye. So anyway, debug draw main menu, which I think we could just call like sort of draw HUD or something, which is a much better name for it because it's drawing all of the trees. We could actually call it draw trees or something like this. I think that's better than debug draw main menu, to say the least. So I'm going to call that draw trees, and then I'm going to recompile. That function is an old function that I think we must have been trying to show how to walk something without using recursion. I don't know why we did it this way. It doesn't make a whole lot of sense to me why it was done this way. And so I think maybe we were doing that or trying to keep from having to pass down a stack thing. I don't even know. But point being, I don't think it's particularly interesting. And so I want to change it into a recursive function because I think it'll be clearer for everyone to read and easier for them to understand if I do it in that fashion. Because we don't need these debug variable iterators or any of this stuff. So debug variable iterator is this utility that we were using. I don't actually know where it is. Debug variable iterator. This thing. Yeah. And it's just like, I don't really want to have to deal with that. I don't want that in the system. I don't think we need it. So what I'm going to do is I'm just going to change this over to being a standard recursive call like it probably should have been, but I'm sure we had a reason why we didn't do it that way. Anyway, so once we get one of these groups, I guess what I could do is call this draw tree group or something. And then I can come in here and say, let's grab this code that's actually used for drawing the tree. And I'll put it in here. Okay. Let's see. This stuff is just sort of the end code. I don't know what the if1 here is for. I'm not sure why we wanted that to be potentially turned off, but I guess that's something in case we wanted to make it so that we don't always draw the interactor. But we'll get to that in a second anyway. So I'm just going to go ahead and sort of make that do its thing. And then I'm going to say, yeah, debug state at y. I'm not sure what that really is supposed to be doing at this point. So I'm going to add a little to-do. Casey, do we still want this at all? In fact, I might just do a quick check to see if I can determine it immediately, and I can. So that's just a useless, now that we have the layout stuff happening, that's just a useless variable, and it can be trimmed. So here we are in draw tree group, and what I need to do is I need to make draw tree group be sort of a recursive function that will allow us to do it in two different ways. So you can kind of see how this works. If the link does not have any children, we'll be in this else case. And in that case, it's just going to execute the element draw. So that's kind of the bottoming out of the recursive function automatically. So we're already in a state where that would be fine. So the only thing we really have to worry about is this case here, where we draw the actual header for this option. And then we look to see whether or not we need to draw the children. So I'm going to say, okay, we've got view collapsible expanded always. I'm going to say, all right, if we're doing that expanded always call, then what I'm going to do is I'm going to call myself recursively. So I'm going to draw tree group again, and I'm going to, well, I should probably have saved exactly what these two things are just so I don't mess it up, although we probably could have figured it out. If we look here, you can see this link children sentinel next, and link children sentinel. That's the list of things that we would want to loop through, right? So those are the things we want to loop through. If I want to, in fact, I could just make that loop happen here even. In fact, I think I probably will. So I'll just say this is like, maybe I'll just call this something more generic, like draw tree link or something like that. And then inside here, I'll call draw tree link recursively with whatever the status is. So I know that this loop itself would be a debug variable link, and I know this is like a sublink of me. It's like a child of mine. Sweet child of mine. Okay, little Guns N' Roses for you there. Not a particularly good Guns N' Roses there. So, you know, your mileage may vary, but, you know, I'm just saying Guns N' Roses. So, assuming that the sublink is not equal to the sentinel. Hello. There we go. Assuming that the sublink is not equal to the sentinel, I want to keep chasing its next pointer, like so. And drawing tree links as I go. So I need to pass some stuff to this. Obviously, when we're drawing things, we need like the rendering group. Well, actually, do we need the rendering group's just known all the time, right? I mean, do we even ever pass this? No, we don't. So we don't really need the render group. That's a farce. That's a lie, a ruse, a falsehood, if ever there was one. So I'm actually going to say no to that. And put this here. And then I'm going to go ahead and say that we pass that layout. Right? Because it's going to open a layout, and we're going to need that layout to lay out the items as we go. So you can see this is a very standard sort of pattern that I often have in the code. You've seen it many times, and I'll just call it out here because we never call it out. It's basically like a three-part method of function calling, right? There's the sort of contextual, there's the global contextual state, which is just anything that's effectively a global variable for all intents and purposes, but it's a global variable that's only relevant to a particular section or thread or whatever, so you don't actually want them to be globals, you want them to be more narrowly scoped than that, but on the whole, that's what this is. This is a pointer to essentially your global variables. Then you have a pointer to what are effectively your local variables. So for this option, for this pass through things, we're laying out stuff. That second parameter is essentially all of the information that's tracked for the laying out of things. And then finally, you have the actual element that you're operating on, whatever that is, which in this case is that debug link, right? And so you can kind of see that's the idea. Hopefully that makes some sense to you. Like I said, you see that a lot in code that I write. I think you probably see it a lot in code that other people write. It's just kind of the way that you naturally there tend to be three general scopes that you're looking at any given time. The immediate item, the context for the operation, and then the whole state for the system that's relevant to this portion of the program. So anyway, I'm going to go through here and call myself recursively, like I said. I'm also going to sweat profusely because it is really hot in Seattle, and I'm with the door closed in a room that is not very well ventilated. So I'm going to go ahead and draw tree link recursively. Again, I pass the layout. I make sure the layout gets incremented on either side here because I want to sort of increase that depth as I go through. But then I don't want that depth increase to persist. So, of course, this layout is now a layout pointer. And so anywhere where the layout actually got used, such as here, is going to be a pointer now instead. So actually these things have to be changed a little bit round, but otherwise most of this code can probably remain the same. So in addition, I'm going to need this tree information because as I pass down this tree, I sort of have two things that I'm operating on. So this is going to be a little bit more complicated, right? I sort of have two things. Again, this is the operation context here, this is the main context, and then these are the things I'm operating on. This tree is actually something that I'm passing separate as well. Now, it is effectively part of this, so really I could, if I wanted to, move the tree into the layout as a thing that was known, because it doesn't vary. But I don't really think that's necessary, so I'm happy to pass these two, right? There's no penalty for me passing them as like more stuff that's on that line. It's just sometimes sometimes you'll see me collapse it down so it's literally just one for this, and the reason for that is I just get tired of having to have people call through. When there's just one recursive function, you won't see me do it that much because it's not a big deal to maintain. But when there's lots of functions that all take them, then like I would start to get annoyed about the fact that I have to pass the layout and the tree when I could have just snuggled the tree in with the layout. So anyway, just a little thought process there. Okay. Moving on, again, the only things that I'm really doing here are just cleaning this stuff up. We've got the frame ordinal now, something that we're also going to want to put up here, which one we're viewing, so we'll get that going. We've got the render group here, that's going to come from the debug state, and so I'm just going to go ahead and pull that out as well. So here's, render group, like so, and that's probably an and. We've got that at y that doesn't have to happen anymore. Draw trees doesn't take the render group, and so we can delete it. And now we're back to where we started. All right, so let's see what we've got. I'm going to step in here. Handmade debug. Handmade debug. Where is my draw tree? Well, actually, you know what? I could just call draw tree link. Wait, what? Is it not called draw tree link? It is called draw tree link. Oh, I can't step into something that doesn't get called. You're gonna have to admit that. Right? So draw tree link, it's got to take the debug state, it's got to take the layout, which we have, it's got to take the tree, and then it's got to take that root group, whatever it is. So a debug variable group, in this case, I guess that, what does that actually have in it? That actually has one of these guys. So we're actually starting out with one of these. If we're starting out with one of those, then it might be better for us to... Well, I guess it doesn't really matter, to be honest. It's pretty easy for me to just do this, and it's fine. And it's a little annoying to have that happen, but it's okay. So here's our group. And here's our group. There we go. And let's see. So here's all of our stuff, and it appears to be rendering correctly, pretty much exactly as it was before with all of the fanciness. You'll notice that already has fixed one bug that we sort of had that's been there for a long time, which is that the depth was incremented on the first time through, so that actually, even though this is supposed to be left flush like it is, it was always indented over. And so that's good. So we fixed that, which is one thing that is obviously nice to fix. So, okay, we're getting there. So that's all well and good. What I'd like to do now potentially is maybe get some kind of a notion of like, well, I'm trying to think of like how we might want this stuff to work. Like now that I've got this drawing in a more sane way, what I'm trying to think of is how I want this system to behave in terms of editing it. Now, one thing I could do, right, is I could go the WIMP style, and I could make these like little windows that you move around. But I don't really like having things work that way. I don't really like having sort of WIMP style stuff. And the reason that I don't like that is because it's really nice to be able to, when I'm not, think about what the window that encloses this is, right? I like not drawing crap over the game because a lot of times, we're trying to look at the game. Like we're looking at the game and maybe we've got some stuff up and we want to be able to see as much of the game as possible, right? I mean, like think about the situation where we're just trying to view this thing here. Maybe I want to sort of get rid of as much of this as possible and just have this thing up and that's it, right? And so I really don't want to make like a bunch of business that's like window chrome that's like preventing me from seeing stuff. So I like the fact that these things are not like sort of heavy in that sense. So what I'd like to do is I'd like to sort of think about that for a second and make a system that allows me to do a little bit more with sort of arranging these things when I want to or how I want to. I'd like to make something that allows me to do that a little bit better and doesn't require any sort of more kind of ridiculous stuff. The other thing that's a little bit, and this was mentioned before, the other thing that might be true is, you know, if I arrange some of these things, I don't know why that, oh, it's drawing behind. I gotta make sure those things draw on top. Another thing that's true is, you know, if we create something here that's kind of the layout for the interface that we, you know, that is how we want it to go, one thing that's kind of a little confusing is, well, you know, do we want to save that somehow? You know, is that something we want to be able to save? And that's kind of another open question. Thinking the answer is probably no, but we'll see. So yeah, so in general, I'm just trying to think about that and how I might want to do that. And similarly, if you kind of look at the way this works, I feel like it's a little bit broken too, in that you always kind of get, when I tear off something or when I'm talking about one of these things, it indents the things inside it, which would make sense if it wasn't the root of the window. But since it is the root of the window, it makes me think that really when we do that tear off, we probably shouldn't bother cloning that root element at all. And these should really just be the things that you tear off, because this is not a relevant piece of UI anymore for this thing, right? So let me think about that for a second. So here's the tear value bit, right? And when you do the tear value bit, you can see that we do a tree add and we pass it a root group. And the root group presumably is cloned off of the particular variable. Yeah, you can see it's whatever this link is. But we're assuming that that link is either itself a group or, like, I guess what we're saying is if that link is itself a group, we really want to clone probably just the stuff inside it. So I'm going to go ahead and take a look at what we do in clone variable group. Oops. Clone variable group. So here is clone variable group, and pretty much what it does is it clones the children if it's got them, right? And so it kind of doesn't do what we would want it to do. It actually, there is no way to say just clone the children of this thing and then put them into like a root group here. And so when we create this root group, I guess one thing that I'm not really sure about is why it's still getting drawn either. Because, riddle me this, when we do draw tree link, remember we did it sort of two different ways. When we loop over the trees, we don't draw the name of this group. So that top group, the group of the tree, should never have its name drawn. So actually what I just said I wanted to have happen should actually be what's happening. And I'm not really sure why it isn't happening. So I feel like we need to investigate and find out what the deal is there, because I'm not sure that I understand what that is. So I'm going to just jump in here for a second. And I want to see, when we come to this code, I want to see what's going on. So I'm going to open this up like I did before. And I'm going to clone this entity over here, and I'll leave it open. And then I'm going to come in here, and I'm just going to say, all right, let's take a look at what's going on. So here's the tree. Here is its group. Here is the name cloned. So it looks like, okay, so when we do that clone, tear value, when we do this clone, are we doing something? That is the call, right? There's only one call, yeah. Interesting. Interesting. So we create a variable group, and then so we're just creating a synthetic variable group for absolutely no reason whatsoever. So that makes very little sense to me. I think what we actually wanted to do here was say that if this thing already was a group, then we wouldn't do this, right? So I think what we really wanted to say was debug variable group result, and then we would say if source children. In fact, I guess we would just say this. Here's the result, right? Or I guess I shouldn't say the result. The thing that we want to clone. Like this is the clone me. Clone source. We want to clone this source children thing, right? If the clone source, or maybe I'm trying to think of how to say this. I don't want to create a new group if I don't need to, right? So instead of doing this create variable group, this clone variable link, which returns a variable link to me, that will actually produce the variable group that I wanted when I do the clone, right? Let me show you what I'm talking about here. So here's the variable link situation, right? And here's the variable group. Now, why these two things are separate, I don't really know, because probably we could just condense them. I mean, it's for sake of one extra pointer. In fact, like I don't even know why those two things are different. You know, there really is absolutely no reason why those two things would be different. I think I might just collapse them. There is really no reason for that. Because all we really need to say is, well, okay, we've got a debug variable link, and here it is. There's the children, right? We don't need to look at that child pointer. We could just use the sentinel, right? That's it. And there's really no need for this at all, I don't think. At least I don't see why there would be. And then, you know, if we want a separate name here, we can put one and then just not use it. It's like I said, it's one extra pointer. It doesn't really seem like a big deal. And we're just adding complexity for no reason. So if you look at these here, right, then instead of, you know, groups, these would just be anywhere you see group, you would just substitute a link, right? And that should do it. Now, it's going to take a little bit of fussing. But I can't do that. Right. That is the real reason. That is the real reason. Is I just wanted to use the trick of having a W-linked list sentinel. Well, I can still do that and not have the added complexity. All I have to do, at that point, I suppose, is continue undoing here. Where was I? There we go. I guess all I really have to do is make sure that these are that is annoying. you can see what the problem is, right? I don't want this to be a separate thing, because there's no reason for it to be a separate thing. But because I'm using the convenience of this being a doubly linked list, you just make the Sentinel by including one of these in the group. But that's just kind of annoying, and it's just an implementation detail, right? It's a thing that's like, I don't really... It's just makes it a little bit easier to be able to do that. So what I would rather do, what I'd rather do is this. And this would be, this is the kind of thing that you wish the language did for you, but it doesn't. What you want to do is this, and just actually point, when you initialize at the Sentinel, you want to point it at this pointer here, right? Kind of nasty, but that's what you would do. And I'm going to do it because I don't like having these being multiple things. I don't think there's any reason for it, so I'm going to get rid of it. So anyway, let's go ahead and change it. So in this case, for example, instead of doing anything where we would do sentinel.next, right, actually what we would do, and in fact what I can do as well to make this a little clearer, I can make a thing that's like debug variable link sentinel. And I can make this do the ridiculousness that would make it appear as if it's a sentinel. So here's my from field. This is my debug variable link that I'm talking about. And I'm just going to say, well, whatever this guy is right here, right? That's essentially where I actually want to pretend the pointer is, right? So basically, I've got this pair, and I want to pretend that this pair is essentially this pair. Does that make sense? I'll move this guy down here so you can see it a little better. So yeah, it's not really a debug variable link. It's a fake one that just exists right here for the purposes of, making our doubly linked list work. Yeah. So let's go ahead and make that happen. All of these remain the same. Basically, debug variable group just changes to debug variable link pretty much everywhere it's used. Like so. And then in here, same thing, really. To start with, all of these are going to be links. Okay. And then everywhere that we were using a sentinel before, we can, if we want to, literally just turn them into a get sentinel call. Or what did I call it? Let's call it get sentinel. And that's really it. So we can just use the get sentinel call and get the sentinel. Same thing in this case here. Get sentinel. Here you go. Yeah. Get sentinel and so on. What is it complaining about? Get sentinel cannot convert. Oh, right. I don't actually need that because that's getting it automatically done for me. So inside here, we want to assert that this link does not have children. So that's just saying that the link first equals get sentinel. So it's empty. is all that's trying to say. And you know what I could do too? I could make that be a thing as well. So if the link first is not equal to the sentinel, and yeah, so I can just say if this guy has children, do a thing. Oops, don't want a semicolon there. And that's about it. So let's see. This is the draw tree link. So if we're going to get the text out of this guy, then we can actually just use this name directly, and that's fine. In here, again, we want the get sentinel. Actually, I guess we don't even need that if we don't want to, though. We can start using these directly when we know what we're doing. So like this link is first. And you know what? I might call these first child and last child as well, just to make it a little clearer what we're talking about. Okay, and let's see. So this is get sentinel. And yeah, that's really just what that is. In this case, we've got, again, another group where we're just going to want the first child. And then here we're going to get the sentinel again of the group. Actually, it makes this, most of that iteration code actually look much nicer. So here is the get sentinel on the parent. Initializing the children part of things. This part we're going to have to kind of actually do now because this is a little bit more specific. Add element to group will be done here. The link that we add needs to have its children initialized, I guess. Although I suppose I suppose this push struct here, well, I guess it is a push struct. So add element to group is actually what initializes it. So here, when we do this, we would set first child equal to last child, which is all equal to the get sentinel on the link. We then have add group to group. This is doing essentially the same thing. When we're adding group, again, we're just adding one of these things. We now no longer really have to talk about adding groups to things, though, for the most part, because basically anything that you add excuse me, is going to be a link. So this is really just creates a link. This doesn't need to create a link because it already is a link. So this one is kind of a little bit nonsensical. So I mean, really, this is just gonna. This doesn't have to do a push struct or any of those things. This is just gonna do this now, and it's gonna use that insert, and it's not gonna do any of these things, right? And it doesn't really need to return a link either. So this is just like add link to group, and you know, it's just doing that. So we'll have to think about whether that even needs to be there anymore. But anyway, create variable group. This is going to do exactly what we would have expected it to do. And when it creates one of these, again, it kind of wants to do what this thing's doing up here. So it's basically doing the exact same stuff. It's going to do this bit here. When the group comes back, it's going to initialize the child thing. And yeah, that should do it. Now, again, these things, I feel like this kind of wants to be more regularized now. I don't know what free variable group, it says it's not implemented, so I'm just going to go ahead and assume that we'll implement that some other time if we actually care about it. I also don't know what add region's still doing there. We haven't used that in years. So I'm just going to keep going in here. So we've got add element to group, and we've got add link to group. They both, and we've got create variable group. They both need to create one of these things. And so it's just a question of whether it's creating one or adding one as an element. So I think what I want to do is kind of make this guy be a little more primal, where we just have create variable link. It's just one thing now. It takes the name if you want it to have one, and then maybe it would take the debug element as well if you wanted it to store a debug element. All of these, if you want, can be set to null, right? You can pass 0 for everything in there, and that would be fine. So I can even do an if name length on here. Otherwise, in fact, I guess I could do this. And I don't know, that might already do that. I'm not actually sure. In fact, let's take a look, because I guess there's no sense in duplicating code. Here's handmade.h. Oops, that's not right. Handmade.h. Handmade.h, yeah. Push and null terminate. You can see in here what it's doing. It pushes a size with the length and everything. So push and null terminate actually is always going to do that push. So I think I am gonna if it here. So I'm going to say, okay, if there's name length, I'll push it. Otherwise, I won't. I have to initialize the other parts here, which is the next and the previous. But that's going to get handled for me. I guess delist init does that, does the first and last. So I guess I don't need that part. I guess I just say that. Yeah. So I just say, okay, whatever my new link is, initialize it, please, which sets the pointers to point to itself. The link itself does have the next and previous parts, which at the moment it's not going anywhere. So I think we want the next and the previous is to point to 0, and then we want the name to be what the name is. So that's how we would create a variable link. When we add this to a group, this one here, where we've got the parent and the element and all that stuff, I think all we want to do now is say, okay, create variable link. Here's the debug state. There's no name for it. It does have an element. Please make it for me. And we can also make that link element come out. And yeah, I'm trying to decide whether I actually want that. Maybe, maybe we'll just even do this. And we'll just set that in here, right? So that seems all good. And then when we get to the rest of these, they just are always calling that, right? So add element to group does its thing. All of these guys basically do its thing. When we create one of these, again, I think we would just call create variable link instead of doing anything fancier. It doesn't have a name. This one doesn't. So it doesn't have to do any of this. And then we set the name ourselves, it looks like. So we wouldn't want to clone it, which seems good. And then we do our thing. All right. So that seems reasonable. We're getting down to it, almost there. Of course, we got some debugging to do, to be sure, but what are you going to do? Sometimes you just got to bite the bullet. So create variable link does not take 4 arguments. I agree with you. I got rid of one of them. And get sentinel of whatever our parent is. There we go. And this is if the thing had children, I guess. So, and let's see. So in this case, we don't actually need to call this, I guess, because we've already done add element to group, and add element to group will create the link for us that we need to add ourselves to. So actually, none of this is necessary. We can just say, well, whatever the thing is that we did, if we had children, we just want to clone those children, right? So really, this is kind of academic. We would just say, we do the clone, and then we say, if the source had children, we clone the children. That's really all there is to it. So that should be simpler. That's actually much easier than it is, than we were kind of making it out to be. Same with that. let's see here. When we do get a create group with name, in this case, this is essentially the same situation. This actually seems to clean up the code quite nicely, in my opinion. So far, I've liked everything, all of the changes that have gone on, thanks to this collapsing of these two types down into one type. So that's kind of nice. Let's see, if this has children was, I guess, what we were checking. I'm not sure why we were checking it, because I guess we... well, I guess we wanted to make sure that it wasn't a link with that name that didn't have children. I think we don't want that. I think we just want to compare it. Yeah, because we want to, yeah, I think so. And so then we're going to say, well, here's the group. If it matched. Then we're going to do a create variable group if it didn't match, and create and add it to its parent. So this is really a create variable link again. And add group to group, identifier not found. So add group to group is just add link to group, right? That's add link to group, yeah. So let me go ahead and change that. Add link to group. Create variable group, declared but not defined. Create variable group. Where was that declared? Was it up here? I don't actually know. Oh, I'm in the wrong function. I mean, I'm in the wrong file. So here is our create variable group and our clone variable group pre-declarations. I hate pre-declarations with a passion. I was very glad to see that John did an incremental compiler, so they would not have this problem in JAI. So we've got clone variable link as one of our things we can do. And we've got, what is it? Create variable link. And so now we just want to fix those up. So here's create variable link. I'm sorry, clone variable link. It does not take 2 arguments. What, pray tell, arguments does it take? So it takes a dest group and a source. So I guess there was, there's one that doesn't take, yeah. There's actually 2 versions. Clever. And one is the one that we want to change that's kind of spurned this whole situation forwards. All right. Let's keep on keeping on. All right. So let's see here. I didn't realize the code was still running. Let's get a fresh build of this and see where we're at. Okay. So debug time. Our link name is null, which is not fabulous. So this is just because we're supposed to be, these are... This is, yeah, we should just check the name there. That's actually totally fine. We're allowed to have null names there, so really we just want this to check. I'm kind of surprised. I feel like our strings are equal should actually take care of that, though. I don't love that, so I actually think what I would rather do is have our strings are equal handle that. Don't actually know where that is. Really got to implement search in all files. I have not had the chance to do that yet, but it makes it really hard. I had that in Emacs. I haven't written it for coder yet, even though it'd be pretty simple. I just haven't had time. So anyway, strings are equal. I could actually just run Feinster if I wanted to, just like the old style, but since I can implement it directly in coder, I felt like it should probably be done that way because it'd be better. So I need to find our strings are equal, but I'm not sure where it is. And that means... Yeah, where did I put that? There it is. So what I'd like to do in strings are equal, when we pass these, what I'd like to do is make sure that they handle, like for example, in this one you can see that it handles the case where where something's null, right? So in this case, I would never be touching, yeah, this function is basically really crappy. This is not a good function because B can be null and it doesn't actually ever check for that, right? So what we probably want to do is say something like, okay, we still want the same strings are equal function, like this one, but we want to make sure that we're not, yeah. I mean, I guess the way I could do this most easily would just be like, you know, if B, then we do it the way we were doing it, right? Do not know why that's indenting the way it's indenting. The mysteries. Okay. Let's see. Do result equals false. So we can do that the way we were doing it. This could probably be simplified a bit, but just for the sake of making this work at the moment, if B is not valid, then we would just say that the result equals a length equals 0. Right? Because if there's no B, then that means that A's length had better be none. Right? That seems better to me because I would rather, all right, I would rather have that do its thing that way. Okay, so we have successfully made that change. Our cloning is working again. So that's all good. Again, pretty simple change. I just wanted to collapse those down. And so now what I'd like to do, since we're basically out of time, got about 2-3 minutes left, I just want to go ahead and make that change where I said, so like when I pull one of these things off, it actually just pulls the group off as its separate thing without leaving the header. And so in order to do that now, sorry, I kind of went off a tangent there, but I just wanted to clean that code up. In order to do that now, what I want to do is during the clone operation, you can see right here why we're having the problem. When I say that I want to clone a debug variable, what I want to do is not ever have this happen. I don't ever want to actually do any of this. What I want to do instead is just do the direct clone and return it. So I just want to do literally clone the source. And now I can do that because they're all the same and we don't care which one it's going to be, right? Whoops. There we go. We allow this to be 0, right? If I say add element to group, oh no, we don't. So I could make that, I'm trying to think if this should just be untangled a little bit. I want to be able to clone this thing and not actually pass it anything for the desk group, which I could do a little slyly by just making this support 0 as the parent, but really these are sort of the same in that sense, if that makes sense. I feel like this wants to be untangled a bit more. I'll skip it for just a moment, but then I think we should probably untangle it a little bit. Anyway, so if we did add element to group, you can see that this is the part that actually deals with the parent. So I can just say if I want to, if parent here, and this will just work. But I feel like this needs to be untangled just a tad, now that we know what it looks like. So now if I do something like pull off the profile, now it's a little more sane. Now like the profile is just like a free-floating thing that doesn't have an actual separate piece here. And I think that's more what I would like. Because now we always can actually draw the other part if we want to, but we don't have to. And I didn't like the fact that I had to, right? So similarly in here, if I'm like doing one of these things, I should be able to select one of these and wonder why I can't select these guys. Yeah. Oh, because we don't have precedence for those. Yeah, that's, never mind. I do know why. So let's see if I can also clone one of these. Yeah. Cool. All right. All right. So I'm going to call it there. Gary Johansson, I feel like I kind of lost the forecast, or forest, I assume is what that was pre-autocorrect, for the trees in this episode. Would you mind recapping? Sure. So here's what we did. Two things. I'll do them in reverse order. The thing we most recently did is we had a struct that worked like this. We had a previous pointer, and we had a next pointer. And the way that those worked is exactly the way you might expect. They form essentially a ring. So, you know, they point to each other. Like this. And they're looped such that this one points back to this one, and this one points forward to this one. So it's a ring. And the way we were doing that is it's much easier to always have something in the list so that you don't ever have a special case. So what you typically do is you insert something called a sentinel, and in this case we had a sentinel, which is just a dummy element that's the same as all the rest of the elements, but it never gets removed. And at the outset, it just points to itself. So at the outset, right, you have the sentinel. Oops. And it just points to itself. So it's like this and this. And then when you come in here and you add a new item, right, it happens to all just work because what happens is you say, well, okay, I need to add a new item. The rule for adding a new item is I just say, whoever the sentinel is, make my previous pointer point to them, right, which would do that. Make my next pointer point to whoever his next pointer pointed to, which is also him, right, because he's pointing to himself. Then just follow my pointers and fix them up. So go to my previous, which is here, and make that next pointer point to me. Done. Go to my next and make that previous pointer point to me. Done. And now we have a proper circular linked list again, right? So in the startup case it works, and of course in every subsequent case it would also work. And so adding and removing from these lists is trivial because you can just run the same stupid, simple 4-line piece of code every time, and it always just works when you have the sentinel in there. You don't need to check to see if the list is empty and handle that specially or any of the other things like that. Okay. But what this means is you need to include the sentinel itself in the structure that's holding this thing. So typically what you do is you say, well, oh, I've got like a group structure, you know, and I've got a link structure. The link is the thing that stores the prev, the next, and the data. And the group is the thing that's like, you know, has whatever the name is, and foo, and bar, and whatever, and there's a bunch of stuff in here. And then finally, it just contains one link, and that link is the sentinel. So there's one of these embedded in here, and the data part is just ignored. That's how you normally do it. But what if I now look at my code and I say, oh, hey, gosh, these two types are really just in the way. I want them to all be the same. There's no reason to have them be separate. Well, you can't exactly do that because if you make these two types the same, this type can't include itself. There's no way to have a group include a group, right? But remember, The only part of the link you actually need to make this scheme work is the previous and next pointers. That's the only part that will ever be touched out of the Sentinel. Because remember, all of these people, they all had data, right? There was always data in here. And when you're talking about a valid link like this one, that data is actually important. But when you're talking about the Sentinel, it never gets referenced. The Sentinel is the definition of pointing to null, essentially. We always check, right, in those loops for, you know, link equals Sentinel, or link equals first child. The link is not equal to the Sentinel. Do some stuff. So we're never going to operate on the Sentinel. We're never going to look at this, which means that technically all we need is that top two pieces. So what I did is I just lied and I casted a previous and next pointer that I have in here, right? I lied and I casted those to say that they were a link struct, even though the rest of the link struct isn't there. Make sense? And so that's that code that you saw up here. See it? So here's the next and previous pointer exactly as I drew them. Here's the Sentinel for the link, so each link can have its own list inside of it. These are what we would want to include. We would have wanted to just type this. But we can't because it can't include itself. So all I did is just said, well, these two things are the same as these two things. It creates essentially the top, the header, right there. And then all I do is just lie and say, hey, that part right here is one of those links for purposes of the Sentinel, right? So what this ends up creating is something that looks like this. Well, you know what I'm going to do? I'm going to draw it a little smaller. It ends up creating something that looks like this. Here's my previous, here's my next, here's my first, here's my last. And actually, you know what? These are in the wrong... Now that I draw this out, it really should be last and first. Oh, no, it's not. It's correct. It's because we had next and previous. Because it's whichever way these go. If it's next, previous, it's going to be first, last, right? So sorry. Let me actually take a second to draw it the way that I actually wrote it down. So next, previous, first, last. Okay? And then, of course, the payload. Oops. Here's the data. Okay? So what I did is here's the struct, and it's part, essentially, of two rings. There's the ring of its siblings, so the things that are the same level as it in, like, this tree, right? So I'm talking about, like, these guys here. Here we go. Here are its siblings. Here's the data. First, last, next, previous. Here's its prior sibling, the one that came before it. Data, next, previous, first, last. Okay? And it is chained like this. There's that next pointer. Here's the previous pointer. Here is the next pointer. Previous pointer goes somewhere we don't know. Here's the previous pointer pointing back to this one. Okay? And here's the next pointer pointing somewhere we don't know. Okay? Make sense? Now it's also part of another ring, which is the ring of its children. Here's its children. So this is its prior sibling. This is its next sibling. I guess I should say previous. Previous. And here is its last child, and here is its first child. Okay? And watch carefully. The first pointer points to the head of this guy, just like the next pointer pointed to the head. Okay? So here's the next pointer. Here's the previous pointer. Here's its first child and its last child in its data. Here's next, prev, first, last, and data, like so. And here this points to the last, again, points to the top of these guys. Okay? But here's the trick. These guys do not point to the top of this guy. If they did, it would create one unified ring of all the siblings and the children. Instead, they point to here. They point to the middle of the struct as if it was the header, but it's not. Okay? And that's how this thing works. Make sense? So it's kind of complicated to think about, I guess. It's the kind of thing, since I do this sort of code all the time, that is just a non-thing to me. Like, I just like, yep, that's how we'll make that pointer happen, and off we go. It's also the kind of thing that I get incredibly frustrated about when people like make compilers that break this sort of thing, or when they see ++ language lawyery or object-oriented stuffness and say that don't do these sorts of things. I hate that, because it's like, this is how CPUs work. They don't know what a struct is. A struct is just a thing that lets me create stuff the CPU does. And this is cooler than whatever it was you were going to do. This is cooler. And I like it. And it's not my fault if your language makes things like this harder to do. That just means you designed it wrong. You designed a crappy language. Not my fault. Anyway. So yeah. So anyway, point being, that is how this works, and so all I was doing was just collapsing it down so I wouldn't have to think about two types anymore. Everyone could just talk about a variable link, and a variable link can either have children or not, and nobody cares. Like, I don't have to have a separate secondary pointer for no reason to point off to a thing, right? Last thing, so I guess, was what were we doing first? The thing that I did first today was we were previously doing a non-recursive walk of this tree. So we have a thing that's like foo, you know, whatever. So we have this tree, and the tree has children. It's like a little, it's like a standard little list view, and you can expand and collapse them, right? And you've seen me play with this thing all the time on the stream. It's this thing up here, right, where I can open it up and do whatever it is I'm going to do. So all that stuff is there, right? And before, we were doing this with what amounted to, excuse me, our own stack. So we just had like a for loop, you know, I think it was actually a while loop, not that it matters. But, you know, we just had a while loop, and we had a stack here that we stored some data with, and we would like walk through this using our own local stack. And I was like, I don't think there's any point in doing that. I don't know why we did that historically. I think it was just to show that you could, or I don't know what we were doing. And it just felt it would be easier to read and more easy to understand and maintain, because the stack is automatically managed for you by the compiler if you just use the actual stack. So recursion lets you use that stack, and because the compiler is set up to more cleanly deal with that, it's easier to read the code. So what I did is I said, okay, forget the while loop. Instead, what we'll do is use a recursive function. So instead of before drawing everything inside the loop, what we do now is we just have like a thing that's like draw tree, link, right? And we call it on one of these guys, and it will loop over all of its children, calling draw tree link on each of those. So if one of them happens to be have children, it will draw those recursively. Does that make sense? Dude in Basement 1, thoughts on linked lists and cache friendliness? I found that a simple array and just coping, I'm assuming copying, when it changes length was way faster. So I guess the things I would say about that is I don't really like arrays, and the reason I don't really like arrays is because they are not orderable very well. Like if I want to change the order of things in an array, I have to copy the whole thing. If I want to add something, I have to copy the whole thing and blah, blah, blah. And I just don't like that sort of movement of that like unreliability of the cost. Like I don't like having operations that are free sometimes and really expensive other times. I just don't like it. So if I'm actually performance evaluating some code and I want to know if this particular code is, you know, I want to try and find the most efficient way to write this particular code, then I might try array versus linked list and see. A lot of people say the phrase to me, I have found that simple arrays are much faster than linked list or whatever. I've actually very rarely found that to be true. In fact, when I was doing performance optimization on the Witness, I found that there was actually no difference between using arrays and using linked lists at all. And so what I think might be sort of true there is I don't know if people are always comparing apples to oranges in that case, because I think mostly the cache friendliness of a linked list versus an array, there's no difference between the cache friendliness of the two unless you're bigger than the size of the cache. And the reason for that is because let's say I have a link, right? And the link has a next pointer, right? Or I have an array, and here's my arrays, like link, 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 link. Well, however much of this fits in the cache versus however many of these fits in the cache is going to be the same modulo however much this cost you, right? So if the answer is that this didn't put you over some cache limit for the size of the algorithm you're doing, is there's no difference between these two things, right? The difference that I think people see is that unlike me, I do push struct style stuff, so all my links are all in the same place anyway, right? So if links are smaller than a cache line or something like this, they all stack up right next to each other and are all on the same page, right? Because the links get pushed right on top of each other all in a row. So they're basically already an array. What other people do is every time is they call new, and who knows where this puts the link. So the links are probably scattered throughout memory in every which way, right? So at that point, that means that however big the link is, right? If the link structure is however many bytes, well, now whatever the amount of the cache line, so it's 64 bytes is the cache line size, right? So however big the thing is, divided by 64 bytes and then the overhang, that amount here is always polluting the cache, which could be significant. Like let's say you make a 68 byte structure, right? Now you're polluting the cache by 62 bytes every time, right? Which is a lot of extra cache fill. Whereas I'm polluting it by 8 bytes every time, maybe 16. And so I feel like when people say linked lists are way worse performance, I don't know if they're really talking about it right. maybe they are, and maybe they were talking about a situation where it was really super high performance critical. Obviously, you want to not have anything extra. So at that point, you may decide that if you know how big the array should be and you know that you're not doing a lot of shuffling, that's going to be better. No question about that. And I would never tell somebody you should use a linked list for performance, right? Those words aren't going to probably come out of my mouth unless there's a lot of shuffling going on that makes it so that an array is somehow prohibitive. But, again, unlikely. But I do often question the people who seem to think that arrays are so much more performant than linked lists, because I've actually never found that to be the case. Are they faster? No. Are they slower? Sometimes, but often not by much. And so at that point, I would rather just have the consistency of knowing that there's no expensive operations, they're all the same, and I have no memory bound weirdness, right? So I know that I don't suddenly have to guess about how much memory I'm allocating or where this thing is going to go. That's kind of nice too. So I tend to not have problems with linked lists. Other people maybe do. Maybe I just don't tend to use them in performance critical situations, so it doesn't matter. And I'm just kind of living off of the slop and don't care. I'm not sure. But I just rarely find it to be that big of a deal, if that makes sense. And Pseudonym73 said concurrency also matters. Linked lists can be better if you need multiple threads working on the same time. Absolutely 100% agree with that. Arrays are real bad in that sense because now you've got a situation where I got to lock down the array anytime I add something to it because I've got to do this whole copy. And I got to wait for everyone to clear out of it as well. There's all kinds of stuff that goes on there. Whereas linked lists, you just do one quick interlock to get off something and that's it. You touch it for maybe a cycle or two. Huber Caleb, how do you feel about object pools as a sort of middle ground between linked lists and arrays? I don't have a strong opinion about this stuff. And like I said, I'm not trying to tell people to use linked lists. Don't take this as some kind of linked list advocacy. I'm just saying that the hype of always use arrays or whatever better than linked lists, I don't know that that's really true. And I haven't seen the definitive analysis of anyone that suggests that linked lists are somehow not a good tool to use and that they're somehow bad. So I feel like, if you care about performance, you need to time it. You need to see what your operations are. You need to think about it. You need to time it. That's just true. And whether linked lists or arrays or come out on top or whether it doesn't seem to matter much, the only way to know is to do that. In the case where you don't really care that much what the performance of this thing is, it's not really a critical thing, then I just have not found linked lists to be problematic. I haven't had that situation where I'm oh my god, these linked lists caused my program to be so slow, and there was nothing I could do about it, or the whole thing is ruined, right? I haven't really had that. And similarly, it tends to be pretty easy to go, oh, these were linked lists, I want to change them to arrays, okay. Usually you can just do that. It takes a day or two of deciding how you want to arrange it or whatever and do the work and port the code. If it's used in tons of places, maybe. But that's it. I mean, you do it and it's done. So I usually don't find it makes much sense to even think about. So I usually write the one that's easier for me to use at the time. If that makes sense. And a lot of times this stuff I meta-generate anyway. So at that point, it's less about me thinking of this. I might just pick, oh, this should be a this should be a that. And I don't have to think about it much. When I'm hand coding stuff, a lot of times arrays are more of a pain to hand code, I find. And the pointers into them aren't stable, which I also find to be bad. If I delete something from an array, all the pointers change and that kind of stuff. And so there's a lot of things I don't like about arrays. I think as a data structure, I don't really like arrays for editable or mute or changing stuff. And so I usually prefer linked lists unless I can really point to a case and go, I care about the performance here, the array is clearly superior, I'm going to use it, right? Because it just adds all this fuss that I don't like. All right, time. Wait, there are? All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along the series on your own at home, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can play around with it. We also have a forum site you can use to ask questions, a Patreon page if you want to support the video series, a tweet bot that tweets the schedule. And I went this weekend. This is how much I love you, Handmade Hero audience. I even went this weekend and learned which Linux distribution was running on the server so I could add the tweetbot to the boot scripts. So the tweetbot should be like indestructible now, because the tweetbot, as far as I know, has never gone down. But it was never in the startup sequence, so anytime they rebooted my server, it killed the tweetbot, because it wouldn't come back up. I would have to log in and restart the tweetbot, because I didn't know where the startup scripts were on this particular version of Linux. Now that I know, I put them in there and I tested that this weekend. So now both the GitHub Authenticator and the tweetbot, which again, literally I know of not a single time they have ever gone down, will now actually appear as reliable as they should have appeared, which is to say never going down, because when they reboot my server, for reasons I have no idea, power failure I guess, I have no idea, they will come back up without me having to manually log back in and restart them. How's that for 9.5's reliability for you? That's about it. I will be back here tomorrow at 5 p.m. Pacific Daylight Time if you would like some more programming action, sweet programming action. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everybody.